Welcome back and welcome to lesson 4, Arduino fast track lessons. This one is the control over Ethernet using the Wiznet and or the ENC26 J60 modules. Both of these modules can be used in an Arduino UNO. The Wiznet is typically one that is on a shield. The ENC26 J60 is typically one that is smaller and connected with flying wires, either with a ribbon cable or just a bunch of loose wires connecting to it. The libraries for both of these now is pretty much 100% compatible with each other, so that aside from changing the library name, your code should not have to change. The initial video that we're about to do will only focus on the Wiznet and the general functionality of the code. The ENC module I will follow up with a separate video just to show how you can introduce that library and not have to do any more than basic changes to the library that you include into the sketch. I want to focus mostly on describing the code in this particular video, and we'll be using the Wiznet for the connectivity for all of this as well. So if you haven't already watched the previous lessons, please go and do so, because if you don't, I'm assuming that you're already knowledgeable about certain things, and I do not want to have to go back over on this one, and I'm not going to. And I don't want to lose you off. So if you haven't watched it, please go and watch them, and then come back to this one. What you're seeing on the screen right now is the web test console that I put together to help with this tutorial. You can download the HTM page directly from the blog entry, and you can edit it, change it, whatever you like after the video, and after you've done the tutorial. But please don't do it unless you're sure of what you're doing before you finish with the tutorial, because it's been set up right now to work with the way that the code is going to be put together. And we'll be coming back to this screen because there is a small configuration thing that you have to do with it, which you can just do with Notepad or something, and I'll show you how to do that in a little while. So the code, lesson 4. Right? Let me just start from the very beginning, and we'll work down and I'll highlight the changes that have been done. We have an additional define, use Ethernet. This allows us to turn on and off the Ethernet as required. I'm not sure if I've caught everything so far, but we've already discussed about using the debug, where you can turn on and off sections of code, and use Ethernet. Once we're done, will allow us to turn off the Ethernet functionality completely as well to recover space. We've added 2 more libraries now from what we had before, the SPI.h and the Ethernet.h. SPI.h is the one that talks to the physical SPI bus needed to communicate with the Ethernet Wiznet card that's going to be plugged in. And Ethernet.h is the specific library for talking to the Wiznet card. It relies on SPI being there. What we've also added in now is another define for the buffer for the Ethernet serial communications. We've got the serial buffer size, which we've already used in the previous video, so you'll know what that's for. Because we now have a different channel coming in, and we don't want to have the issue of them both writing to the same one, because it depends on how quickly things come in. We've set up another buffer of 50 bytes for the Ethernet. You can normally have way more than this, but the way that we're going to work this lesson is to actually use a technique where we don't send in big messages, alright, and we don't return big messages either. We limit the amount of data going to and fro to make the whole system more responsive. Now the parameters we've already seen. I've added 2 more. I've rearranged the delimiters slightly here because some of them you can't actually send over Ethernet. They get escaped into different things, like a space, for instance. Won't actually delimit properly through the Ethernet. Also, one of the common delimiters for Ethernet when you use a get query On HTTP is the ampersand and the question mark, so I've added those in to help. As you can see, I've changed up the defines for the pins to make them more sensible for what we're using. As we go through and we get more and more advanced on these videos, we'll put more and more sensible things into these that are getting away from beginner terminology. So we have the first three outputs, and they're on pin 2, 3, and 5. The inputs correspond to in0 and in1. They're actually on pin 7 and 8. The SPI pins, you've reiterated them here. I already talked about those. I2C pins, there are two of them, SCL and SDA. These are for talking to liquid crystal displays, A to D, D to A converters, and other things. For this particular lesson, we're not using them, but I've already excluded them just so I don't have to worry about it later. This basically reduces us down to only having two pulse width modulation channels. One is on pin 6 and one is on pin 9. The next section that's been added is a standard block of definitions that the Ethernet cards will use. We define a MAC address, which is the media access control layer address. This is used by the local network only. It doesn't go over the internet specifically for communications, and it has to be unique on your network, otherwise other devices will get confused as to where they need to send traffic to. The TCP/IP port is resolved down to a MAC address once the communications is running. The next thing is the IP address. This needs to obviously be unique on your network. The one I've got here is just unique on my internal network at the moment. You will have to probably change this to something else. Typically 192.168.0. something or .1. something, depending on the router and the DHCP you have set up at home. I'm not going to try and tell you how these all need to be set up. If you don't understand what these settings are, then talk to somebody either in your household. If you're a youngster and your dad looks after the network for you, then ask him what you need to set these to, or whoever it may be that looks after it for you. The typical port that a web server works on, because we're going to be setting up a kind of web server in this case, is port 80. So this here is starting off or initializing the server class for the Ethernet server, and it's telling it to use port 80 here. We're also initializing a client. This is often done inside the functional code further down, but because I want to be able to share this client with other parts of the code, I've moved the actual variable into the global area for now to keep things simpler. As we did with the serial port, we're also defining a character buffer set to the Ethernet buffer size, which, if you remember just above, was set to 50 bytes. This is the serial buffer stuff that you had seen before, and we also now have a new int for the Ethernet index. Alright, so the serial index you already know, we count through, we keep track of where we are with the buffer. The Ethernet index is the same thing, but for the Ethernet buffer. Enums and all this stuff we've already talked about in lesson 3. We have changed things up a little bit, not in the messages, they're exactly the same as they were, but in the commands and things that we had before. So I've removed some of the digital command indexes. I've removed the PWMs and some of the analog ones, and I've added get MS. If you remember when we talked about the web page, we have the ability to get the milliseconds from the Arduino. Digital all JSON. What this is a command that says to the Arduino, give me all the digital ports, which is the DO out 0, out 1, out 2, and in 0 and in 1. Even though a port is set as up as an output, you can actually still read its state. JSON is a format. It's you'll see a little bit later on what it looks like, but it's a very, very compact way of sending data back to a client when asked for. If you use something like XML, it is very verbose and takes a lot longer to transmit it. So JSON is a great thing for small devices and mobile devices to use for communicating. So coming down here, most of these we've already covered off. Again, reduced the and deleted the ones that are no longer applicable. We've added the new ones like analog old JSON. We also have a digital old JSON for which we were talking about just a moment ago, and the get milliseconds. These are the actual strings that have to come over the internet to work. Now, one of the other weird ones you see here right now is this one here, which is get. When you use the serial port, we were doing, and in lesson 3, we were doing things like Web 5, Analog 2, Digital 0, and things. When you use a browser to communicate with a server over the internet, what happens is it uses a query string. Typically, that's what we're using. You don't have to, but we're using query strings. And at the beginning of every query string, which gets sent to the port on the server, is the word get. Alright, so this is seen as the first parameter, so we have it in here so that we understand we're getting a get command from the internet, and we can take appropriate action. So if you sent something for the analogs, it would actually be get and then analog all JSON. If you were trying to adjust a PWM, it would be get PWM1 and then the value after it that you were sending. So we'll do a little bit of a tweak with the debug messages later so that you can see what happens when these commands come in and see what they look like. But for now, just take my word for it that that's what it does. Coming down here now, all the command table obviously adjusted the same as the rest, and we've covered how we do this in lesson 3 as well. Same old, we've already covered this. So in find command, we already know how that works. In setup, we've added the initialization for the Ethernet port. You see they're wrapped around with these compiler directives, so if we turn it off, we just have to change one statement and all of the Ethernet will disappear. Slight modification to the initialization of the inputs and outputs to reflect the changes in our pin assignments. No changes to this, and in the loop statement you'll see that the basic one here for serial is still there, and there's an extra command been added to the do command, and when you're using this from the main loop, it's hard coded to just send an empty string in. You'll see later on why this is done. There may be a better way of doing it, but I'm trying to keep it simple right now. The additional piece of code in the main loop is the check for the Ethernet. You can see we've got a check serial method, which we've already talked about. We have another method now which is almost identical for checking the Ethernet. And if this returns true, then we will call do command. This is exactly the same do command. It doesn't matter whether it's the Ethernet or whether it's the serial port that got the data. The only difference is which buffer you're passing in. Okay, and then the client.stop is stopping the listener of the Ethernet port once we've processed any commands, so we don't waste time. Normally this is inside, but because we're doing things in other functions, it's been moved into this main loop. And that's the only change in the main loop here at all that we've done, so that's pretty good that we keep this simple. There's nothing in this code so far that is blocking at all. There's no delays or anything like that. In the do command, what we've done here now, you see this extra parameter that we've added in. So you've already seen this one with the command buffer. The character pointer param is a second parameter that will handle the situation where if we've got something from the Ethernet, remember I said it has the get command at the very first parameter. Well, that really is irrelevant to us. We want the second parameter and the third parameter, which is the actual value parameter, if any, to be used. So what I'm using with this now is a technique called recursion, where the do command function, which is still basically the same as it was before, will actually call itself with the modified command as they come through. So I'll describe that as we go through, but let's just go down the first part of the code here. So we had do command, the command parameter and the parameter as described in the lesson 3. I've added another one called parameter 2 so that we can capture the additional variable that's going to come in from a web channel. I've also changed the initialization of analog value from 0 to -1. It just made things simpler a little bit later on. Mainly for toggling digital values, because if you send in the digital command with nothing, this was defaulting to 0 before and therefore was turning the output off. With the -1, if you just send a digital 0 command, it will actually toggle the output, and I'm just making use of that on the web page to keep things simple as well. Command stratoc is the same as it was before. With the parameter stratoc is the same as it was before. We've added an additional one here, parameter 2. The way this works is still exactly the same as the previous ones, and we talked about that in lesson 3. We're just picking up the third parameter using the delimiters, and we're assigning that to a third variable. Now what I'm doing here is this next piece where it says if the character at address of parameter, so this is address of and then the first space, is equal to a empty string character, which is the 0 to say it's a terminator, that means we didn't get anything in the parameter variable. Right? So that's either because we didn't pass one in, or it's because we're doing some kind of recursion and we've come back again, where there is none in the command like the main line, because it's already been passed out, because it's gone through these three once already and now it's going back in on itself. The second part of this check is if there's no parameter and the param, which is the one we passed in here, okay, right now it's always, all you've seen is it being hard coded to /0. So we're saying if the parameter, the main parameter is 0, but we've passed in a secondary parameter on the main function call because it's saying it's not 0, then whatever we passed in, make it the main parameter. That's all this really does, is just saying if a parameter came in on the main function call and we didn't pull one out of the main buffer, then just assign it. Okay, I moved the debug statements up here a little bit just for convenience so that we were printing them out before we processed them. Because of the way recursion works, and we're calling ourselves a little bit further down this code, if this was at the bottom, you would actually see the printing in the reverse order that things were happening. So moving it up here, it means it prints before you call itself, which means that your output is in the correct order. This is exactly the same. The find command is exactly the same, and you can see these things here are identical as well as far as how they are functionally working. It's still a case statement. It behaves exactly the same as it did in lesson 3. We've added the get statement, and this is the only place right now where the recursion is occurring. So what happens is if it sees the get statement as a command, you see here we're calling itself again. Only this time round we're taking the parameter, which was actually the second variable that was on the command buffer, and we're making it now the first variable, and we're taking parameter 2, which is the one that came in, which we derived earlier, and we're actually making that the second variable passed into the function call. So if you go back up to the top, this do command parameter 2 ends up being the command buffer, which now only has parameter, and param is actually being assigned to parameter 2, which was the one that was pulled out in this statement here. This allows us to recall ourselves, and effectively we're shifting all the parameters across one. So then the second time through, say we said get analog old JSON. The second time through here, we're going to have analog old JSON as the command this time, and then it's going to call the function get analog JSON, and then it's going to pass in client. Now if you remember up above, client is actually the Ethernet client that we initialized earlier, so now we're passing in a pointer to it. The reason for this is we need to be able to output these strings back to the client, and I don't want to have massive big buffers to build up any content. So by passing a pointer into this function, we can have the function itself do the writing back out to the caller, which is in this case the web page. Later on we'll probably expand this to take the client and a flag to say whether we're talking to the serial port or whether we're talking to the Ethernet, and have a bit more decision logic. Right now we're keeping it simple, so we're just passing in the Ethernet client so that we can talk back to the browser. The get milliseconds is the same thing. We're passing in the client. Analogs is the same as before. Digital all JSON is one of the other functions where it is called through the recursive nature. So the first time through it's going to get the get, that's going to recall itself, and now it's going to pick up on get all JSON, and it's going to call this function that will send out the Ethernet port, the digital I/O of the Arduino. Digital 0, 1, 2, 3, 4 works exactly the same as before. They don't actually return anything to the Ethernet port. They will print out diagnostic information to the serial port though, because that code is still in there from before. But when you send things out the Ethernet, you don't have to have responses. So if you're just saying turn a light on, you don't have to say come back and say that it's done it. And in the case of our console right now, the digital port indicators are not automatically updated. They can be easily updated by adding a single line to the browser code, and you can see that when we look at it later on. But for now, for the sake of the tutorial, we've left it where you have to hit the get values button. PWM 0 and 1 are also instances where with the Ethernet it's going to hit the get first, it's going to do the command again, and then the second time through it's going to hit these. In fact, anything that comes from the Ethernet that tries to talk to all of these, it's going to do the recursion, which is the basically calling itself. So you can see we've added these extra commands, but structurally and functionally it behaves exactly the same as it did in lesson 3. So check serial, none of this has changed, it's exactly the same as it was before. Now what you're going to find here that is going to be really interesting is that this code here is check Ethernet, and if you look at this you'll see that aside from the few commands at the very beginning, which is basically seeing if there's a connection, so has a browser connected to the Ethernet port, do we have a client set up, is the client connected, and is there any data available on the Ethernet port, and if there is, so while the client is connected and while there's data available, we're going to start doing this middle loop. And if you look at this, this bit of code from here to here, I literally copied and pasted from the serial buffer code and just pasted it in here, and the only changes I made to it was changing the name of the buffer to reflect the Ethernet buffer instead of the serial port buffer. But that's it. It actually behaves in exactly the same way. So, you know, it is possible that I could actually abstract this code and put it into a separate function and shrink this one and the serial port one down even further. For now I'm not going to do that though, because I don't want to make things too complicated in too quick steps. And that's the end of the Ethernet. So really that's all there is for talking to the Ethernet port, is the initializations you've already seen up above, and then this one function called check Ethernet. Outside of that, everything else is working just as regular set of functions. The do command is completely, it doesn't, you know, it's agnostic to whether the data came from the Ethernet port or the serial port. By that I mean it doesn't care. Alright, it doesn't care where it came from. So going down here, we've got some small functions just to help offload the complexities of the main loops. So we have the get all digital JSON, which is designed to return an HTML response to the caller, which is obviously our web page. We have the analog version, and the main difference here is that the function code 200 just outputs the basic header information required for an HTTP response, and then the JSON digital response outputs the bit that is specifically JSON formatted code, where it's going to read the digital ports, format it into the right string, and return it to the caller. The analog does exactly the same thing, and the code 200 is the same for both, which is why I separated it out to a function. This is the get milliseconds function, and as you can see, it too just says send the header information, and here, because it's so simple, I've just wrapped it up in here. It's not worth creating a subfunction for doing the main loop, where the Ethernet client, that should be CL, sorry, minor mistake there, CL. It actually will be exactly the same because the client is the global variable where I'm keeping references to it, but it's actually CL here, so to keep the code correct it should be using CL. So it's sending out a squiggly brace and then a quote value, close quote, colon, and then a quote, and then the millisecond, which is the actual, the binary value, the numerical value of how many milliseconds the board's been up and running for. Then it closes the quote, closes the squiggly bracket. The /n sends the new line character, which is the OA, back to the caller as well. You could do a print ln as well, and it would append this on the end, but I prefer to keep this simple and actually have control of this visibly, so that you know what you're sending in and out, and you don't, it's easy to forget that the print line is there, and it can mess you up sometimes. So is numeric is the same as it was before, so I'm not going to bother talking about that. Free RAM exactly the same as it was before. So now we have the set PWM. We were using this in the in lesson 3, and this has not changed one little bit. It still does exactly the same as it did before. Get analog does exactly the same as it did before. Get set digital, it does exactly the same as it used to do. And if you remember, I said that I had changed the value initialization up the top to a -1, and what happens here now is when it comes in, because it wasn't an analog, because you didn't pass in a 0 or a 1 or any parameter into the digital call, it'll be initialized to a -1, and here we'll just use that, and we're automatically seeing the -1, and we're just inverting whatever the pin is. If it was high, it'll make it low. If it's low, it makes it high. Now, this also handles the digital input ports, not just the output ports. And what happens is when you write a high to a port that's been initialized as an input, it actually turns on the pull-up resistors that are built into the microcontroller. When you set it low, it will actually turn them back off again. So if you're reading switches, you don't have to have an external pull-up resistor for those switches. You just connect the switch between the input pin and ground, and you just turn on the pull-up resistor, and that's enough. So you can actually keep your bill of materials down a little bit. As you can see, this doesn't send any data to the client. I'm not passing in the client here, so it's not talking back to send any kind of acknowledgement at the moment. It still does, though, send out the serial port to say what it's done. Alright, so that's the same as it was doing with lesson 3. Process web command is exactly the same as it was before. This is a new one now that we've added, which is the JSON digital response. So this is reading all of the digital ports and formatting a response. Now, this is exactly the same as what we had for the get milliseconds, except that it's been extended to encompass more than one parameter. So we still got the starting squiggly brace, and then JSON formatting is basically name value pairs. So it's digital 0 as text, and then the actual value that it read from the digital port, digital 1, the output, the value it reads, digital 2, the value, digital 3, 4, etc. Right? And then it closes it off the same way and puts a new line character at the end of the response string, so it knows it's all done. The analog response is exactly the same as the digital response, where it starts with a squiggly brace, it reads the puts the name, reads the analog port, and adds the value to the end of that one, repeats it for analog 1, analog 2, and analog 3. Now I haven't put these into program memory space yet. I will do that again as we go through future lessons, because we got plenty of RAM space right now, so I'm not worrying about it for the moment. And I wanted you to be able to see what we're actually outputting easily without trying to run around all the different bits of code. So most of these ones that are outputting to the Ethernet port, they all start off by writing code 200. HTTP 200 response code is the accepted response code that indicates that everything behaved correctly. So if you actually look at the data going back to the browser, you'll see it literally will have these strings at the beginning of it. HTTP 1.1 200 OK, content type text XML, HTML, and then connection closed. Connection closed actually tells the browser, in this case, that once it's got all the data, close the connection to the server that you're talking to. And this is a mandatory requirement that it would do this. And the reason we're doing this is because the Wiznet can only handle 4 connections. So if you want to have 2 browsers talking to this or something else like that, or the ability for other things, if you've got the browser sitting there or the connections being held, nothing else is going to be able to connect to it easily. And the current level of the Ethernet code, even though the chip is capable of handling up to 4 connections, the code itself, from what I understand, can't. So the less time you spend holding the connection open, the better. Right? The 404 is when you get an error message. Right now this is not being output to anything. It's here just for completeness, and we will be using it when we start using the SD card and things in a later tutorial. So that's really it for this code. As you can see, we haven't added a huge amount, and what we have added I've kept contained within individual functions. So this, it's just formatting a string, which is for the digital, and sending it out, processing web we're not calling from the browser. So there's not, even though this seems to now be a very long program, it's still broken up into small manageable chunks that you can look at within its own right. Like even the check Ethernet, which is the biggest addition to this particular lesson, has not got massive amounts of code in here, and 90% of it works exactly the same as the serial port code did. So if we compile this now, let's just run it on the compile here. You see how bigger it is. It's now 17.5K. Now the minute you bring in the Ethernet library, that brings in a lot of code that has to deal with using TCP/IP stacks, UDP, DHCP, a whole bunch of functionality that comes in that we're not necessarily using right now. So if I quickly open lesson 3B, which is our let's just save that. Yes. So if you open lesson 3B and compile this, all right, you'll see that this is going to be what, 7.9, so 8K. Okay, now we open lesson 4 and we compile this one, and we're sitting at, I think it was 17K. So we've gone from 8K to 17.5K. So we've added almost 10,000 lines of code, and as I said, most of this is library. So if I upload this to the UNO board now, And yes, I do have this running on an UNO. Some of the community actually had some problems earlier with a piece of code where they were reading from an ultrasonic transducer and things like that, and they were running out of RAM, but they hadn't done any of the optimization techniques that I've been describing in these videos, and so the only easy way to get it up and running at the time and to validate the code was to put it onto an 18 mega 2560, which has 256K of RAM, of flash space, and about 8K of RAM, so there was no way it was going to fail for that, so we were able to get the code running. But right now, even with this, we actually have more code here and a lot more functionality, and yet we have way less RAM being, flash RAM being used, and way less actual RAM being used. So if this is now running, it's uploaded to the board. So if I actually open the serial monitor now and have a look, you'll see, there it is. It's going to introduce its little hello thing, and now what it's doing is, remember we had the debugging. The web page I've still got up and loaded off to the side screen here. So what you're seeing is the debug print that's happening. If I just stop this for a second, so this is the initial command that comes in. It's broken out into its individual parameters. I'll show you before the end of the video what it looks like in its raw state, but there's the get command. I put pipes in the printing just so we can delimit between the different commands. It's got the get command as the first parameter, analog all JSON as the second parameter. The no cache equals is something that the web page is actually sending in to prevent the web page from caching the old pages. So it's it's a technique that you can use for more advanced work where a server might be caching pages and giving you stale data. By making the query string unique every single time, it prevents it from doing that. Anyway, this is the first one where it comes in, and as you can see, it's got 989 bytes of RAM still, so we're just below 1K. Now we can improve that a little bit by moving some of those strings into the flash RAM, but remember, we've added a whole Ethernet buffer, Ethernet library. We've added an extra 50 byte buffer, so we're still not doing bad. There's 989 bytes of RAM free for this. So this is the first call through. Remember I said we did recursion. So this is recalling do command. And remember I said that the parameters get shifted slightly. So here's the analog JSON, right? So the first time through it gets the get, which has got that call to itself again to do command. This is the second time through now where the analog all JSON is now the first parameter, and then no cache is moved across along with it. No cache is irrelevant, and there's nothing that's going to respond to that. But I'm just showing you what's happening here with this, and it's doing the analog reads, and it's just every second it's doing another read. You can see the RAM is not being chewed up. All right, if I put it back on auto scroll again a second, it's not using more and more and more RAM, so everything is behaving very, very nicely. Now what I'm going to do is I'm going to hit the get milliseconds button on the browser. If I bring this into view a second, right here, so you can see it, I'm going to hit this and see it's updated because I just uploaded, so it resetted the counters. I can hit it again, you see it's changing value every time. And if I hit the get values button, alright, if I turn on a couple of these lights, alright, see now it's reflected the changes I just sent out. Now if we quickly bring this out of the way and stop this, if I go back to where this was all going on, alright, here's the first digital all where I click, sorry, where's the get millisecond one? There, here. Here's the initial one that asked for the millisecond. So there's the get, and there's the second parameter, the get milliseconds. Alright, now it did the recursion and recalled itself, so now the get milliseconds becomes the actual command, and now it can do what it needed to do. Alright, and now a little bit later down here we did the same thing, but we hit the get the digital button, and here's the get, and then with the recursion it did the digital all JSON and did its bit of work there. Alright, and the parameters just shifted across with it as well. And then I hit that a few times, so there's another instance of it here This is the one where I actually sent the command. Remember what I said, if you get a -1 on the digital, it's just going to flip-flop the bit. So here we're saying get digital 0. That's going to hit the get statement. It's going to recall do command and then moving the parameters across to the left. So there it is becoming now the main command. In this case we're still writing status, so it's saying digital 2 was 0. Okay, here's the one for digital 3. This is the pin number, by the way, that's on these ones. Anyway, there's digital 1 and there's digital 2, which is actually pin 5, and it's saying there was 0, and now they're not going to be 0, of course. And now it just went back and started resuming doing all of the analog reads, which again is happening every second. So that's scrolling all the way down there. Alright, so let me just stop this running for a moment. Let me just close this serial port. You go down to the check Ethernet. Alright, right in here there's a every character that gets in. Alright, here's the character buffer client.read. If I actually put in here a serial.read .write, and the character buffer, what this will do is every time a character is read from the Ethernet port, it's just going to echo it out of the serial port. Now hopefully it'll do this all together without other things getting in the way, but we'll see. Let's just upload this to the board. That's busy compiling and uploading. Okay, I just turned off the printing at the top of the do command section just because it was cluttering the screen up and it was difficult to see what was happening. So if I just pause this now, what you can actually see here, this is the actual, it's just one line of it. This is exactly what is being sent out from the code on the web page to the Arduino. So it's sending the get, remember we talked about that, and then it's a space and then a slash analog JSON, analog old JSON, and then an appsend no cache equals blah blah blah, finishing with an HTTP /1.1. This is the complete minimal amount that you would have to send from a page to be able to get any data from it, properly formatted and everything else. So you can see this is the first command, which is a get. The command we're really interested in is this one here. Alright, so that's why we have the ampersand and the slash as delimiters, because the first talk is going to split on this, the next one's going to split on this, and therefore we've got this one. If I actually allow this to continue and I hit a command like changing a PWM value, alright, let's just stop that a second. Okay, so here you can see that I've done a get, and then it's got the slash PWM0 and then a comma 135. So here's the we don't want this parameter, but it's the first one. Here's the main command that we're really interested in, which you've seen in the recursion, and then the next one that we're interested in is the 135. So there's a comma in there, and then we've got the 135. The comma may not be the correct parameter. I probably should have a question mark in there or something like that to be correct, and I could change that on the browser and it wouldn't make any difference. It would just continue to work because the question mark is also one of the parameters that's allowed. Or I could even just put another slash in there, it would still work. Okay. Anyway, you can see here though that now that we've added an extra command with a slider, you can see the different values, 120, 125, 130, 135, as I slid it from the left to the right. They're being sent out and talking to the Arduino to get the data. Right? Because I was sliding it quickly, some of this was showing up quicker than the serial port could deal with it. And then it went back to the standard analog reads again. Right? Now if I run this and I actually do the same call, like analog old JSON, but do it from an actual like as a main browser. So it's 192.168.1.24. 7. Right? I just did that without any parameters there, and you can see it sent the GET and it sent the HTTP, but it didn't have any parameters in there. This is what would typically be sent from a page if you didn't say anything. Now what we want to do is add to this is the analog alt JSON, which is the actual command. So I'll add that to the browser query and run that. Now if we just quickly, alright, so here's what happened when the browser did it versus the code that's running as a script on the browser. It did the GET here, which is get analog JSON HTTP 1.1, but it also did this. This is one of those weird things where there's nothing I've got in there that does this, but the browser's asking for fav icon, which is really, it puts it into the URL line in the top left hand corner. If it finds it, it'll just show the nice little icon, which of course it's not one of my commands, so it doesn't know what to do with it, so it just prints this debug message saying it doesn't understand it. And then the other page goes on and continues printing. Now what I will show you is what, I just basically executed the command from the browser. If I come here and show you, this is the actual string that resulted from the command. See, there's the command that we sent, and here's the string that came back. So you actually don't need to use this nice pretty page that I built. This one here that's still sitting there ticking away. Every time these things, every time this ticks and asks for a page, asks for a data from the analog ports, what it's actually getting back is just this, with a little bit of the header information, which was on the HTTP 200. But what it cares about is this bit here, and that's what it's taking, and then it's stripping it apart into its individual name value pairs and putting them onto the gauges to adjust their values. Alright, and the gauges are doing this bit of work here. So let's take that off. So yeah, that easily now shows you what actually happens when this thing's running. The only difference is the scripting of the web page is doing it in the background. Anyway, that's the end of this lesson. It feels like it went pretty quickly, but I'm sure once I check to see how long this video is, it probably wasn't. The next lesson is going to be building upon this one. We're going to start using the SD card. Right now for this lesson, this web page, as you can see, is coming straight off one of my hard drives on the local computer. In the lesson 5, when we start using the SD card, this web page is actually going to be delivered by the Arduino as well. We're going to put these pages, and we're going to put a nice pretty 404 page and a few other things actually on the SD card with graphics and everything, and then it'll be completely self-serving. So you just go to the page, you ask for, and it will return this to you in the browser, and then it'll start working away, reading all the analogs and everything else. I mean, everything else will be working the same way. We're not going to change what the page does or how it behaves. We're just going to change where it gets served from. So a lot of people have been asking how to use SD cards and how we can use them for doing a web server, and a lot of people have struggled with it. So what I intend to do is, now I've shown you how you can communicate with the board using TCP/IP, using the Ethernet adapter and everything else. Lesson 5 is going to say, okay, we've got all this nice stuff working, but now let's pile a bunch of pages onto the Arduino board on the SD card and let it have a lot more things. Okay, different pages could be connecting to different Arduinos as well. You can put them on all of them, and if you've got a few of them with an Ethernet port on, they can have different address. You just have a primary one that has all the pages, and then it communicates with the other ones just to start doing the functionality just like this one. Anyway, I hope you like this. Please provide comments, feedback, etc., to the forum, and what I'll be doing is, I'm not going to go through all the code again on the next video, but just one more video for this lesson before it's complete will be to use the ENC card, right? The ENC26J60 modules. This one, through the whole of this, use the Wiznet, and what I want to show to you with the next video is that now the code is good enough in the ENC. It'll take up more RAM because it doesn't have the same level of hardware abstraction of the TCP and stuff like that kind of functionality that's in the Wiznet chip, but you can get the ENC boards up and running quite easily. The difference is you'll be able, if you're using a Wiznet board, you'll be able to get a lot more functionality coded into it, into the Arduino, because of the fact that some of the functionality is offloaded to the card for dealing with the networking. ENC is it's a Ethernet level device. It's not doing anything on board for TCP/IP or UDP or any of those other things. It all is getting done in software, which means the library ends up being a lot bigger. But you'll see that in the next video. Alright, anyway, I hope you enjoyed it. I hope you can make use of this. I hope you can understand it. And stay tuned for the next one.